Hello everyone, you are watching Code with Shubhajit, and today we will be solving our first hard problem, uh, that is trapping rainwater from LeetCode. Okay, so let's get started. This is a very famous problem actually, the trapping rainwater. Let's go through the problem statement once. We have been given n non-negative integers representing an elevation map where width of each bar is 1. Compute how much water it can trap after the raining happened. Okay, so we are given an array as you can see, and this array, each of the elements are actually the height of the bars. Okay, so these black bars which you are able to see, these are the height of the bars. And now whenever the rain water pours into them, they will be storing some amount of water based on the left and the right height of the like bars which they have. Can you see? And we have to actually calculate the total amount of water which will be trapped. So just by looking at it, can you see that here we will be having, and the width of the block is 1 and here is the height. On the left, can you see there is the height. So this is 1 unit of water, let's say, right? 1 into 1, 1 unit of water. Here also we have 1 unit of water. Here we have 2 units of water. So 1 plus 1, 2, 2 plus this 2, 4, and then this one is 5 and this one is 6. So we have a total 6 units of water here, or can you see the output as 6? So this is the thing which we have to uh, calculate. And now I will go to the OneNote to explain you more about the approach, and then we will code it out the solution together. Okay, so here I have taken the same example as I was explaining. So in this we have to devise an algorithm that will actually calculate the total amount of water which is stored. Okay, so the brute approach which is coming to my mind is, whenever I am at any of these elements, let's say this one, okay, I will traverse through the whole array, and then see that, okay, which is the element to the right which is having the highest bar, and which is the element or which is the bar height to the left which is the highest bar. So let me take example of some middle bar. Let's say this one. Okay, let's say this bar with a height of 1. So on the left, what is the maximum height bar which I have? I have this one. And on the right, what is the maximum height bar which I have? This is 3, right? So I will see that, okay, to my left there is a block maximum height of 2. To my right there is a block of maximum height 3. Now I know that above me how much water will be there. Okay, above me I am of height 1. Above me how much water will be there? Can you see that how much water will be there? If this is of height 2, this is on the right is of height 3. It's definitely that the water will be till height 2. The water will be till height 2. Why? Because the minimum is 2. So it's the minimum of the left and the right. And my height is already 1. So I can only hold 1 unit of water more over my head. So this block, if I am this block, then I can only hold 1 unit of water more over my head. Right? And now let's go to this one. If you see this, this is with height 0. To the left, again, it has a height of 2 as the maximum block. To the right, it has again a block of height 3 as the maximum block. Now here, what is the height of water it can store above it? It can store 2 units of water. Why? Because now it has a 0 height, so it can accommodate the 2 units of water, which is the minimum of this one and this one. Right? You can go to any block and you can calculate the amount of water there. If I go to this block, okay, this one, let's say, and if I see on the right, what's the maximum height block I have? I have maximum height block of 1. On the left, what is the maximum block of height I have? It's this 3. So on the right I have 1, on the left I have 3. What is the minimum of that? The minimum of that is 1. And this 1 is already a height which is lesser than my height. So I will not be storing any water above me. I would be able to store the water if this right block height would be greater than 2. Will it be 3, 4, 5, whatever? The left is 3. If let's say this one was height of 5, this block was height of 5, then I can actually store 1 more unit of water because the left block maximum height was 3. I hope you are able to understand the algorithm which we need to develop here. Okay, so this is one approach where for each element or for each block, I will be traversing the whole array again to compute the left and the right max block, and then based on that I will calculate that how much water above me I can hold. So that will be a big O of n square approach, because for every block I am again traversing the whole array. So it's n into n, that is n square. Can we actually decrease the time complexity here? We will decrease it with the same logic of the left and the right thing which we are doing. So the approach would be, if we are able to store the left and the right maximum block height for any block, let's say for this block, if we are able to store that, okay, the maximum block height on the right is 2 and the maximum block height on the left is 3, if we can store that somewhere, then we can do this operation in place. That is, okay, the minimum of 3 and 2, that is 2, I am of height 1, so the amount of water I can store is 1 only. So we can do it in big O of 1 for this each block, right? Taking this array again, and now we will be actually storing the left and the right max for any of the blocks in an array. Okay, so we'll be having two arrays here. One is the left max array, and the other one is the right max array, right? So let me actually do that here. Left max array, and here is our right max array. Okay, and I will be writing them down here. How will the logic go on? So for the left max array, I will be traversing from this index and I will be traversing till the right. For the right max array, as I have to find out the right most maximum height of the block, I will go from here till the 0th index, like from the last element till the first element I will go. Okay, so let's get started with the logic. So this block, which is the first block, what is the left max of this? Definitely there is no block on the left of this, so every time the first element will be a 0 only. Okay, this is 0, and for the right max, the rightmost element will be 0, because on the right there will be no blocks. So starting with this, we have 0. Okay, now we come to this point, that is the block with height 1. Now we will check, okay, what is the left max of this? If I see that left max is till now 0 only, so I will update it with 0. But now I see that this one what I have is actually greater than my 0. So I will also be having a left max value. Okay, I will also be keeping the track of that to actually update the height of the blocks while putting elements in this array. So left max value was 0 till now, but now as we have encountered a block with height 1, I will actually update it with height 1. Okay, now when I come to this point, okay, that is the third block, which is of no height. What is the left max for that? For that, the left max height is 1. Fine. Now I will again compare, that is 0 greater than this 1? No. So 1 will be the left max value only. I hope now you are able to understand how the algorithm is built. Okay. Now we have this 2. What is the left max? The left max value is 1. So I will put 1 here. Okay. And now as 2 is the height of the block presently, I will update the maximum value with 2, because 2 is greater than 1. Now we have a block of height 1. What's the left max of that? It's 2. Now I will check that is this 1 greater than 2? No, it's not. So I will not update this left max value. Okay. Now I have 0 again. What is the left max? It's 2 again. Okay, good. Should I update? No. What we have now? 1. What is the left max? 2 again. Should I update? No. What we have now? The height of block 3. So what's the left max? 2 again. But now should I update? Yes, because 3 is greater than 2. Okay, now I am here with the block with height 2, this one. So what's the left max? The left max is 3. Should I update it? No, because 2 is lesser than 3. 3 is still the maximum value. What is the left max for this block with height 1? It's 3. Should I update? No. For this 2, it's 3 again. Should I update? No. For this 3 again. Should I update? No. It's done. Fine. Okay. Now I will be populating my right max. For that, I will be going from in this direction. For left max, I am going in this direction. Okay. So as I have told, the initial element will always be 0 due to the reason that on the right of this block, is there any element? Is there any block we have? So the right max is 0. I will also have a right max value which is 0 for now. Okay. But I have encountered a height of 1. So the right max value will be now 1. Now I am here, the block of height 2. What is the right max block height? It is 1. Should I update the right max? Yes, 2 is greater than 1. So I will update it. Fine. Now what is the right max for this height of 1? That is 2. Should I update? No, 1 is lesser than 2. Again I am encountered with 2. What is the right max? It will be 2 again. Should I update? Not required because they are equal. Okay. Now a block of height 3 comes. What is the right max? The right max is 2. Should I update? Yes, 3 is greater than 2. So I will be updating the right max value here. Now we have 1. Block of height 1. What is the right max? The right max is 3 now as we have just updated it. Should I update it with 1? No. 0. Again 3. Okay. Will not be updated because it's 0 lesser than 3. 1. 3 again will not be updated. 2. 3 again will not be updated. 0. 3 again will not be updated. 1. 3 again will not be updated. 0. 3 again will not be updated. So I hope you are able to understand what is done here, right? So we have the left max array, we have the right max array, which actually stores for each block what is the left max value, for each block what is the right max value. And in this way, whenever we are traversing this array, this height block of heights array, we can do it in big of 1, that is the constant time. So if I write the logic here, it will be a for loop running from 0 for I is less than n and I plus plus. Okay. And there, what I will be doing, for each block, I will be checking what is my left max, what is my right max. I will be finding the minimum value of my left max. Let's take it as LM. Right max, let's take it as RM. Whatever the minimum value I will get, let's say some min val. I will get some min val. And what I will do, I will actually see that if this min val is actually greater than the height of the present uh, block which I am standing on. Let's say at this point, right? At this point, the left max is 1. If you see, at this point, the right max is 3. So what is the minimum of them? The minimum of them is 1 only. So I have a height of 0, and the min value is a height of 1. So yes, 1 is greater than 0. So I will check that is this height of I, is this height of I uh, greater than, sorry, is this min val greater than the height of I? If that's the case, then I will actually add. So I will also take a water is equals to 0. Okay, the total water is equals to 0. What is the answer? So water plus is equals to min val minus height of I. So this should be the logic. Okay, this is the rough logic which I have created. And if you see here, if I will go through the whole solution here, what is the left max? 0. What is the right max? For this one I'm telling 3. What's the minimum of them? 0. Are we making any like water stored? No. Let's come here. What is the left max? 0. Right max 3. What's the minimum of them? 0. I will not be able to store any water because the height is only greater. Coming here, left max 1, right max is 3. So the minimum of them is 1. Now I am able to store some water because the height is 0, the minimum value is 1. So I'm able to store the value 1 here. You can do it for everyone. So here it will again come, for this it will come 1, for this it will come 2, for this it will come 1, the same logic, for this it will come 1. If you make it a total, 1 plus 1, 2 plus 2, 4 plus 1 plus 5 plus 1, 6. So this is the answer, and that's the same answer which we have scene. Okay, I hope you are able to understand the solution. We will need to code this out. Before that, I also want you to give the time complexity of this. The time complexity for this should be a big O of n. Why? Because we are traversing the array once, not once, actually thrice. Twice for creating the left max and right max, and once for actually finding the total water. That is big O of 3n. Okay, which actually boils down to big O of n. But if you show this to the interviewer, then he will be able to understand, okay, you have an idea of all the processes which have happened, right? And the space complexity is big O of 2n. Why 2n? Because we have taken two arrays for storing the left max values and the right max values, which again boils down to big O of n. But showing this again is good. Okay, now let's get to the code part. Okay, so starting off, I just want to have the n for storing the length. Then also here I will be initializing all the variables which I will be needing. So int left max array is equals to new int. So I'm creating an array for the left max elements of size n, where I will be storing the left max values, and also I will be creating a right max array similarly with same n with n values. Currently there is nothing inside them, so we will be populating them in the below steps. We will also be taking the left max val is equals to 0 and the right max val is equals to 0. We will also be taking the total water is equals to 0 for now. Okay. Now we will start with the algorithm where we need to populate the left max array and the right max array. So what's the algorithm for that? Uh, for int I is equals to 0, I is less than n, I plus plus. Okay. So in the logic, when I have explained what I have done, left max array of I will be populating with left max value. Okay. And now we will check that, okay, is the left max value still the left max value? Like, has the height of I, if it is greater than the left max value, then I should update it, right? So left max value is equals to math dot max of left max value and the height of I. I hope you are able to understand. I'm just comparing that, is the height of I greater than the left max value? If that's the case, I will be updating the left max value. Okay. This is done. Now what we will do, we will actually do it again for the right max array. Right max ARRI is equals to right max value, and same thing here. Okay, so this is done. Yes, we have missed one point. What is that? So I will be starting from n minus 1, I is greater than equals to 0, and I minus minus. If you remember, uh, in our case, for the right max, we are going from the last index towards the 0th index. So that was something I was doing wrong. So I will start from the last index, that is the n minus 1th index. I is greater than equals to 0 and I minus minus. Okay. In that case, we are working good. Okay. So both the left max and the right max array are populated now. Okay. So after this, I will be calculating the total water. For int I is equals to 0, I is less than n, and I plus plus. And what we should be doing, we should see that wherever we are, minimum height, what is the minimum height from the left and the right? So that will be math.min of the left max ARR of I and right max ARR of I. So that is the minimum height. Okay. And now we have to compare this minimum height with the height of I. If this minimum height is still greater than height of I, it means there is a chance to get some water stored. And what will be that? That will be minimum height minus height of I, right? So uh, total, I think total water I have taken. Yeah. So let's copy it only. Total water plus is equals to minimum height minus height of I. This should be height, yeah, height of I, and that should be it. Uh, and here I want to return the total water. Okay, let's run the solution and see if it works or not. Okay, there is an error, and I understand where I have done it. Coding fastly, I just missed that part of the semicolon in the last line. Oh, come on, we have a lot of errors. Okay, so okay, I got the error. Hmm, this is not an int, it's an integer array. My bad. Sorry guys, apologies for that. But yeah, while coding you will have some errors definitely. Ah, okay, now I have to check. Yeah, here again I have done some mistake. Right max val. Okay, it means that there is some error with right max val or what? I cannot see anything else. Let's run this. Okay, now they passed. Thank God. So yeah, there were some minor typos and some semicolons which were missing, but that's fine. That happens when you code and when you learn. So I'm also a learner, learning each and every day and also sharing along the path. Okay. So this is it, guys. I highly encourage you to take some more examples, dry run the logic on them, and see how the flow is going on. And there you will understand more and try to code out the solution on your own. Okay, that will help you build that logic in your head. And some similar problem in later time, if it comes, then you will be able to solve it, right? Okay, and please submit it and see if all the test cases pass or not. It might or might not be. So if not, then try to change the code to make the test cases pass. But for now, I hope you are able to understand the whole solution, the whole logic, and I hope it was helpful. If you have any doubts, please put them in the comment section. I will be really happy to help. And that's all for today.